So we learned how to balance a chemical equation. All right. So we learned to balance a chemical equation using hit and trial method. Okay, that part is clear, right? So now let's see some more conditions, more conditions on a chemical reaction. More conditions. More conditions of a chemical reactions. Okay, first one. There can be effect of heat, sunlight, pressure, etc. Means a chemical reaction can be influenced by these factors. For example, let me show you. Silver bromide. This is a compound. Silver bromide is a compound. When we are exposing silver bromide to the sunlight, the silver bromide get decomposed into silver and bromine. Understood? Okay. Br2. So we know how to balance, right? See. So this is the reaction. Here, see, the effect of sunlight is represented like this. Now, how to represent heat? Let's take calcium carbonate, CaCO3, limestone. When we are heating calcium carbonate, okay, what we get? Calcium oxide plus carbon dioxide. Okay. Here, this calcium oxide is also known as quicklime. Quicklime. This is also known as limestone. See how I represented heat. This sign delta, no? It represents heating or heat. Okay. So, even heat can influence a chemical reaction. Sunlight can influence a chemical reaction. Similarly, pressure can also influence a chemical reaction. Okay, if a chemical reaction is influenced by pressure, we will represent it using, see, suppose carbon monoxide is combining with hydrogen. If I am applying a pressure of 340 atmosphere, this is how pressure is represented. Okay, CH2OH. Okay, see what happened here. Now let's see the effect of pressure, how it is represented in a chemical reaction. Let carbon monoxide is reacting with hydrogen gas in the presence of pressure of 340 atm. Then we get alcohol. Alcohol is produced. Methanol. Okay. We learn about alcohol and all in your 4th chapter. Carbon and its compounds. Okay. But see this chemical reaction. How the effect of pressure is shown here. Now let's balance. How to balance? H2. 4 is there. So 2. Okay. Carbon monoxide is a gas. It's a gas. It's a liquid. Okay. See, this is also a method. I will teach you. See, why I put G over here? The carbon monoxide is in gaseous state. So I am representing it by G. We learned by balancing the chemical equations. No, I taught you the last step. We'll represent its physical states. So here hydrogen, it's also a gas. I'm representing by G. Alcohol, it's a liquid. So I'm representing it by L. So the first effect is what? Heat, sunlight and pressure. And this is how it is represented. Now let's see what is the second effect. Second condition. Second condition, there can be liberation of gases. What? Liberation of gases. For example, when I am heating calcium carbonate is a solid. What is formed? Calcium oxide, quicklime, that's also what? Solid. Plus, what is formed? Calcium carbonate, when heated, gives calcium oxide and carbon dioxide. Okay. Here, gas is liberated. Okay. Carbon dioxide is a gas. Either you can represent it by G. You can represent it by G, or else if you are putting an arrow like this, see, arrow which is pointed upwards, this also implies that the carbon dioxide formed here is gas, is in gaseous form. Understood? Either you can represent it by G, or the arrow which is pointing upwards also represent that it is a gas. Okay. Now what is the third one? Second point, third condition of a chemical reaction, the effect of a catalyst. Okay, effect of a catalyst. Have you heard about catalyst? What is known as a catalyst? See, catalyst, okay, before that I'll show you. Suppose a material A is combining with another element B. A is combining with B to form C. Suppose this may be a very slow reaction. It will take a lot of time. And if I am putting another substance X, then this reaction becomes so fast. But the matter of astonishment is that this X does not take part in chemical reaction. This X does not take part in the chemical reaction. But what it does, it will increase the speed of the chemical reaction. So catalysts are those materials which increase the rate of a chemical reaction without taking part in the chemical reaction. So what is a catalyst? Catalysts are those substances which increase the rate of a chemical reaction without itself being consumed in the chemical reaction. So which is the catalyst in this chemical reaction? This is the catalyst. Okay, understood? Now the fourth condition is the precipitate formation. Precipitate formation. Okay, let me represent a chemical reaction. Let lead nitrate is combining with sodium iodide. Okay, sodium iodide, and we are getting sodium nitrate and lead iodide. Okay, lead iodide and sodium nitrate. Okay, okay, let this be the reaction. Here, after the reaction takes place, suppose if you are adding lead nitrate and sodium iodide in a test tube. Okay, and once the reactants are formed, you can see something, some deposit, some froth or something visible. Insoluble things are there in the reactant side. It will be visible. Either it will be in some colored material like white precipitate formation, some precipitate is formed. So in this reaction, the precipitate will be lead iodide. How will you represent the precipitate? See, a downward pointing arrow represents the precipitate. So what does that mean? If suppose it's not clear, write one side. See, PbI2. I am showing like this, plus NaNO3. Okay, see, the downward pointing arrow represents the precipitate formation. So if there is a question, which is the precipitate formed in the above reaction? What is the answer? Lead iodide. And this reaction is a precipitation reaction. So precipitate is the fourth condition. Now we are coming to the fifth condition, physical states. Okay. Physical states. Physical states. Physical states I have already taught. When we are writing a chemical reaction, we will represent the physical state of each particle that is participating in the reaction. Like solid, we will represent in brackets. Like if it's a solid, we will represent it as S. If it's a liquid, we will represent it as L. If it is an aqueous state, we will represent it as AQ. If it's gas, we will represent it as G or a upward pointed arrow. For example, carbon plus oxygen combines to form carbon dioxide. Carbon is a solid. Oxygen is a gas. Okay. Carbon dioxide is the gas evolved. Okay. Understood? One more example I'll show you. See. Sodium chloride. Solid. It's combining with water, H2O. It's liquid. If you are putting salt in water, what happens? Salt solution is formed, right? Means last year you in class standard 9th you studied about ions, right? Means sodium ion Na plus and Cl minus is formed. This will be what? Aqueous. This will also be aqueous. Means what? They are the solutions. Aqueous means solution with water. Alright. Okay. That's it about the more conditions of a chemical reaction. So we learned about physical changes, difference between physical changes. We learned about chemical changes. Then what we learned? We learned how to balance a chemical equation. We learned about balanced and unbalanced chemical equation. Then we learned about more conditions, different conditions that influence a chemical reaction. Now next we are going to different types of chemical reaction. There are different types of chemical reactions. Here in this chapter we are going to study about 5 different types of chemical reaction. The first one is combination reaction. Combination reaction. Then we will learn about the second one. The second one is decomposition reaction. Decomposition reaction. Then third one, we learn about displacement reaction. Displacement reaction. Then fourth one will be double displacement reaction. Double displacement reaction. And fifth one will be redox reaction. Okay. These are very important topics. Okay. So, and balancing chemical equations. That is also a sure shot question for your examination. There will be a question from the topic balancing of chemical equation. Then there will be another question from different types of chemical reaction. Okay. So we will study each reaction in detail. Okay. So coming to the combination reaction. Let's see what's a combination reaction. So here in this type of reaction, what will be happening? The name itself suggests that combination reaction, which means combination is happening. That is, in a combination reaction, two or more reactants combine to form a single product, Okay. For example, if on a reactant side we are having one reactant A, another reactant B, the product form will be single, which consists of both these reactants. Understood? One more. For a product side, if I am combining three reactants, on a reactant side, the product will be consisting of a single product. Got it? So what is a combination reaction? A combination reaction is a reaction in which two or more reactants combine to form a single product. Example, see, carbon, burning of coal. In burning of coal, carbon is combining with oxygen to form carbon dioxide. On the reactant side, you can see there are two reactants. One is carbon and the other one is oxygen. But on the product side, you have only a single product, that is carbon dioxide. So this is an example. Burning of coal is an example for combination reaction. One more. What? Formation of water, hydrogen combining with oxygen to form water molecule. See, here also on the reactant side there are two reactants, but on the product side you are getting only a single product. So these are the examples. Formation of water and burning of coal is an example of combination reaction. Okay, now we are coming to the second type of reaction. What we learned, what we are going to learn. Okay, combination reaction. The second one is decomposition reaction. So can you guess what will be decomposition reaction? What will be happening? The name suggests it. Decomposition means what? A single reactant decomposes to form two or more products. So in a decomposition reaction, single reactant decomposes to form two or more products. Okay, the representation can be done by C. Suppose this is the reactant, it will be decomposing to form two different products. Okay, suppose another ABC, a reactant, is decomposing to form two different products. Understood? So this is known as decomposition reaction. Okay, now there are three different classification of decomposition reaction. Let's see what are the three decomposition reactions that is coming under this. Okay, the first one will be, in a decomposition reaction, first one will be thermal decomposition. Okay, second one will be electric decomposition. Okay, and a third one will be photolytic decomposition. Okay, now what do you mean by thermal decomposition? This can also be known as thermolysis. Okay, thermal decomposition is also known as thermolysis. So what will be happening in thermal decomposition? Thermal means it is something related to heat. For example, I will show you a thermal decomposition. when calcium carbonate is heated, see, heating, thermal decomposition, heating, it gets decomposed into calcium oxide and carbon dioxide. Okay, here the decomposition is happening in the presence of heat, so this is known as thermal decomposition. So likewise, what will be happening in electrical decomposition? If this is happening in the presence of heat, in electric decomposition it will be happening in the presence of electricity. Okay, what is another name for electric decomposition? Electrolysis. Okay, so example for electrolysis, see, when we are passing electricity through water, the water gets decomposed into hydrogen and oxygen. This is known as electrolysis of water. This is an example for electric decomposition or electrolytic decomposition. The factor that is playing here is electricity. The factor playing in thermal decomposition is heat. So what will be the factor that is participating in photochemical decomposition? Photolytic or photochemical decomposition. It is also known as photolysis. Okay, photolysis. It will be what? What will be taking part here? It will be light from sun. That is, sunlight is the factor. Sunlight is the factor. Can you tell an example? Can you tell an example for photochemical decomposition? See, when AgCl, silver chloride, is a compound, when it is exposed to sunlight, it gets decomposed to Ag and Cl. Okay, this is the example for photochemical decomposition or photolysis. So these are the three different decomposition reaction: thermal decomposition, electric decomposition and photolytic decomposition. Okay, got it?